All right, friends and neighbors, it's time now for an actual build. We're going to do a VoIP build today. And by way of explanation, or maybe some initial conditions here, this is the topology that I'm going to set up. And so right here with me, I'm in the lab. And let me just give you a quick overview of the equipment that we're going to use. Here is the rack. You can see that we've got some equipment sitting there, and then maybe a couple of PCs here. And there we go. So let's figure out our topology first. If you have spent any time with me, you know that I like pictures, I like cartoons. So I'm going to use Paint to help me out with this topology. So I've got a router here, and what I'm going to sort of imagine is that the router is going to divide this into two networks, as would be indicated by the fact that we have two interfaces. So that means I'm also going to create a couple of VLANs on the also Now, what are my networks going to be? Well, maybe we'll do something like this. We'll keep it simple, and we'll do maybe 192, 168. We'll do the 10 net. Okay. And over here, we'll do the 11 net. And we'll occasionally refer to this diagram as we go. Important things to us will be, what are IP addresses that we're going to use, and then certainly the MAC addresses. So why don't we go ahead and get started with the router config. So we'll bring up PuTTY here. And here I am connected to my router. Oh, I'm not connected to the router. One second, let me connect to the router. All right, now we're in the router. Now, I suppose while we're waiting for this thing to settle down, what we ought to remember is that for a VoIP configuration, my router here is going to be my call server. It's going to be my TFTP server, and it's also going to be DHCP. So here we go. So I'm just going to do the interfaces first, and we'll make F0/0 the low numbered networks. So, and I like routers that are high in the range as far as addresses go. Do no shut on the interface. There we go. So my interfaces are up. Now, they're not doing anything right now, right? They're just interfaces with IP addresses, but the minute we have link lights, we should get a routing table, but for this small topology, I'm not even going to worry about that right now. What I am also going to do right now while we're here is take a look at a couple of things before we proceed. So I want to make sure that my router has the necessary files on it to be a call server. And what I'm looking for, at least in a Cisco config, are SBN and loads files. So I'm just going to do a dir on my router, and I can see that I've got, the files that I need. So I'm happy. So let's go ahead and do our DHCP server. Now, a DHCP server on a router is pretty fast, quick, simple, and easy. So I'm going to just do IP DHCP pool, and then I'm going to give it a name. I'm going to create two DHCP pools. One will be for the phones, and one will be, say, for PCs. But initially, really, the reason for having two of them is so that I can test with my PCs to make sure that both sides of the router are working. So we'll call this one computers. Whoa. And the network for the computers will be 10.0. As I said, we're going to set them both up, but let's also do a default router, which of course will be my router. And that's actually about all we need just to get us started. But what I'm also going to do is a DHCP pool for VoIP. And the network here will, whoops, do the network first, will be 11. And our default router here will be this, the 11.254. Now, we know that the router is also going to be a TFTP server. Now, the order of operations for VoIP phones is first they get an IP address, then they need a TFTP server to get not only the files that they need to operate as a phone, but also to get the config. So what we need is an option, a DHCP option that allows us to do that. And the one that we're going to use is option 150. Now, question mark is your friend. So we're going to see here, what are my arguments? Well, we're looking for an IP address. Now, who is going to be the TFTP server? Well, it'll be the router, and it'll be the router interface that I want to use for my phones. So I'm going to use 192.168.11.254 because I've decided that's going to be the network for my phones. There we go. Now, if we take a quick look at my config so far, all that I have are these two small DHCP pools and then my router interfaces. That's it. Now, if I look at my topology here, since the 11 net is over here, maybe what I'll do is I'll say, well, you know, what's really going on here is that my call server and TFTP server are going to be over here, right? And the only thing that I'm going to be doing on this side is DHCP, but of course I'll also have DHCP running over here. All right, well, why don't I go ahead and hook up the wiring for that, and then I'll show you what that looks like on the video. So as a quick view, you can see that my router is hooked up, and I've got a bunch of cables into the switch for testing. There we have it. The orange one there is my my laptop, so that I can show you that in the video. So if we take a quick look at my IP address here, we can see that I pulled an address on the 10 net for my wired address right there. And just for fun, real quick, I'll pop over to the other one. So the interface comes down, and we'll wait for the link to come up. I could have done spanning tree port fast, but I guess I'm too lazy. Now, I just realized I forgot something. We've got currently two router interfaces that are actually in the same VLAN. So what I'm going to do right now to separate not only my PCs and my phones, but also to make sure that my two DHCP servers aren't fighting with each other, let's create our VLANs. So as you can see from the prompt change, I moved over to the switch. So let's create our VLANs. There's a couple of ways to move ports in and out of a VLAN. I'm going to put 6 ports together, but initially you might do something like this. You just go to the interface and you say switch port, access, VLAN, and we'll do 10 and 11 just to match with our subnets. That's a good, or our networks, that's a good engineering practice. So I'm going to say VLAN 10. Now, if I take a look at my VLANs, I can see that VLAN 10 was just created and I've got port 1 in there. But that would be kind of inefficient if I wanted to do that for a whole bunch. So I might use my interface range command, interface range, and now I'm going to move the rest of them in there in one go. Like that. And the impact of that was to put all of them, oops, I wanted to do 6, didn't I? So let's do, we'll add 6 to this. There we go. All right, now I'm also going to add 6 more ports to VLAN 11, which isn't created yet. So I'm going to use the same command. We'll do 7 through 12. And we'll do switch port, access VLAN 11. Take a look at our VLANs real quick. There we go. And you can see that I've created my two VLANs. So this gives us some separation. Now, hosts in VLAN 11 should get network addresses on the 11 net, and folks in VLAN 10 should get addresses on the 10 network. And our DHCP servers won't compete with each other. Now, just while we're waiting here, let me show you what that looks like on the rack. So those were my VLAN boundaries and where I've got everybody connected on the switch. Now, I made a quick mention of spanning tree port fast earlier. What that does is goes through the spanning tree port states very quickly. In fact, it skips listening and learning and goes right to forwarding. Why are we mentioning that? Well, we know that a port takes 30 seconds to come up into forwarding using spanning tree. But the problem is that phones are very picky about that. Phones need their IP address, they need their configuration right away. And if they have to wait for 30 seconds, a lot of times they won't actually connect to the call server. So what I'm also going to do right now is set up spanning tree port fast so that my ports go forwarding much faster. And I'm going to go ahead and do that with all the ports that I'm using right now. This is effectively the same thing, and rapid spanning tree is defining an edge port. There we go. We can see the warning from the switch right now. Okay. Let's update my IP address. There we go. And so I switched my PC over a while ago while we were futzing around, and so now it's on the 11 network. So both my DHCP scopes work, but in the 11 net I also have the option 150, which my PC isn't paying attention to, but there we have it. Okay. So we know that we've got a couple of VLANs out here, so why don't we go ahead and label those. So on this side, if we were maybe doing this, we might say it's not exactly like this, right? Because the PCs are not aligned the way that they are on the diagram here. Whoops. Let's get rid of that. We're actually VLAN 11. Okay. Well, that does it for our base configuration. So now I guess it's time to start working on our telephony configuration. So we need this guy back again, but we need to talk to the router because we have to do a couple things. We have to set up the telephony service itself, and then we have to set up our ephones. And the ephones have two parts. They have the ephones themselves, and then they have the dial numbers that go along with the ephones. But before we do that, we probably ought to keep track of the MAC addresses. So the phones that we're using today are the trusty Cisco 7961s. And on the back of them, they have the MAC addresses. So I'm going to record those for use later. So what we'll do is on our diagram here, we'll go ahead and record the MAC addresses that are going to be used. So this one is 001B D5. What is that? 84603F. Now it's kind of important to get this right because the call server is very picky about MAC addresses. So I'm just going to double check 001 BD5 84603F. All right, so that's this one. And we'll double check 001 BD5 8470E1. All right. That sets us up nicely for the next step. Now, if we are really excited about this, we might be tempted to plug the phones in right now and see if they get their IP addresses and everything else, but that's kind of a mistake because we've got to do all this configuration and then we'd have to plug the phones back in anyway. But we're going to go ahead and do the router config first so that we don't have to unplug the phones and plug them back in again to get them to find everything again. So let me go over to the router. All right, we're on the router. All right, I decided to blow up my font a little bit so it might make it easier to see. So we're going to go config T and we're going to say telephony service. And we see the prompt changed. Well, we've got a whole bunch of things that we can do here. but we need to do a couple of things like tell the router which interface we want to be the call server and something about the phones and things like that. So let's take first off the call server itself. So we need to say which interface is going to be our call server. IP source address, and we are going to use 192.168.11.254, but we're not quite done here because we need to define a port that we're going to use. Now, Skinny uses port 2000, so that's what we're going to use. There we go. Okay. Now, this warning here, the clock is not synchronized. Well, the date of this router is wildly, we're probably decades off right now. We will solve that problem later on. We don't need to solve it now. We don't need to solve it to get our phones to work, but it is going to be a problem when we want to have an up-to-date interface. So we'll fix that later on. I'm not going to worry about it right now. Well, we're also going to define how many phones we're going to use. So we've got this max keyword here. So we're going to do max dial number. And on this, we'll set maybe 10. We'll do our max ePhones, also 10. And that's pretty much it for the telephony service. We've said where we want to serve up phones from and how many phones we're going to allow. Now we can do one more thing here. We can do a system message, and this will appear on the top of the phone. We'll just say howdy. Okay, let's exit this, and we've got two things to do for each one of the phones now. And maybe what I'll do is put this side by side here with the MAC address that I want to use. So there's two things we need to do. We need to define an ePhone, and then we need to tell that ePhone what its phone number is and what the MAC address is that it goes along with it. So that's the next two parts, and we've got two phones to configure here. So let's make this phone that we can see on the left here ePhone 1. So we'll say ePhone 1, and you can see my prompt change. Well, what do we have to do here? Well, we got a couple things to take care of. What I'm really worried about is this command right here, button, and then the MAC address. So let's take care of the MAC address. There's a particular format that we have to use here. So 001B point or dot D5 84. So these are groups of 2 bytes. And then 603F. There we go. Now the button command is for these buttons right here. And the first number is the button itself, and the second is the ePhone number that you want assigned to that button. So I'm going to say button 1, just regular digits here, and so I'm going to do this. Now I get this error number. What I want is to assign that dial number to this particular button, but I haven't defined the dial number yet. So let's do that. So I'm going to say, ePhone, let's get this out of here. ePhone dial number 1, and again, my prompt changed. And we're going to say, my interface timed out there. So we're going to say ePhone dial number 1. And what number are we going to do? What do we have to do here? Well, we can see we've got a lot of things that we could do, but all that I want right now is the number. So the number is going to be, and we'll just for fun, we'll use the RIT exchange 475, and this is phone number 1. So we'll say 1111, just like that. There we go. Now, if we go, we go back over and we go back to ePhone 1, now I can say, I look at the button command and I say, well, 1, and then what can I do? Well, let's try and assign it to that one again. Now we've got no error. Now, theoretically, we're very close to being able to configure a phone, But what I'm going to do is move over to the other side of my screen so I can see that other MAC address. And why don't we go ahead and take care of our other phone. So let's go ahead and do the dial number first because we know that that's coming. So we'll do ephone, ephone, dial number 2. And the number for this one, since this is phone number 2, oh, for heaven's sakes, we'll do 475-2222. And let's go ahead and define the phone itself. ephone 2. We need the MAC address, as we can see here, 001B. Is that D584? Yeah, 70E1. Like that. And then we'll do button, and we're going to assign button 1 to ephone dial number 2. All right, I like it. We're really close to being done here, except that we haven't done our TFTP server yet. So let's take care of that. But I'm going to show you a little shortcut here. So we know that if I do a dir, I can see the files that I actually need. Now I'm going to show you a quick way to serve up all of these files. There's probably an even faster way, but what we need is to be a TFTP server. And I'm just going to highlight the files that I want, one at a time. And then just right-click, File Name. Now, it's possible that the phone is already loaded with a lot of these files. But there we go. So that's how you would do it. Well, just for fun, if I was doing maybe wireless phones or things like that, we see, these guys here. But a lot of times the phones have been updated. We don't need all of these files. But there we go. All right, now I'm going to do one more thing. And I'm going to say, go ahead and create those config files. There we go. And the timestamp hasn't changed on those, so that's a problem because I haven't updated, but we should be good to go on the config. So I'm going to go ahead and plug the phones in, and we'll see what happens. Now, this might take a second. I'll see if I can, we'll see what the interface does. Oh, an important note here is that we want to make sure that we plug the phones into the correct VLAN. If they don't, then we won't get option 150. Now, hopefully you can see some of this, right? As the phone gets plugged in, I've got power over Ethernet on my phone, or on the switch, to power up the phone. And we can see that the phone is trying to come up and do its DHCP discovery. It'll do TFTP, and then we'll do some skinny stuff. Let me plug in the other phone. So we can see we got a little power light there. We're trying to come up. And it might be easier if I pick up the camera. You can see on the front of the phone, it's got the phone number 475-2222. So we know that this is ephone number 2. And if you look in the lower left, you can also see that it says howdy there. Well, my other phone has come up, 475-1111, and so let's try and make a phone call. Always nice when a plan comes together. Well, there we have it. There is a very simple skinny phone build. Let's do one more thing while we're at it. And you can see on the screen here that I've got my phones and they have registered, right? We can see these messages here. That's an important set of details. There are a couple of show commands that we can do. We can say show ephone. All right, some details. You can also do variations on this, all kinds of modifiers to this. And so there's several modifiers to that. So there's lots and lots of things that you can do, even on Call Manager Express, to see what's going on, or whatever call server you have. There is one other thing that I want to do though, and that is to set up a monitor session to see what's going on. So let's take care of that right now. I'm going to plug into the switch. Now, if I want to watch what's going on between some devices on a network. We used to hook up hubs or things like that, but one of the easiest things to do is to set up something called spanning or mirror. We're going to do a monitor session. They're all pretty much synonymous. So now I'm on the switch. Now the key is where's your source and where's your destination. Now my phones are connected to ports 11 and 12 looks like, and the monitor that I'm using, this machine right here, is in port 23. So if we update our diagram a little bit and we say, well, this is port 11, this maybe is port 12. My monitor is in port 23. And oh, by the way, you know, over here we have ephone 1, right? And this guy over here was ephone 2. There we go. Let's go ahead and set up a monitor session so that we're watching what goes on in between ephone 1 and ephone 2. It's pretty simple. I'm going to set up a monitor session. Most switches can support a couple of them, but it makes the switch kind of busy. And I'm going to say, oops, monitor session 1. Well, where do I want the traffic to go? Who is the monitor? So I'm going to say the destination interface is F0/23. Well, where am I watching? What is the source? Well, the source is, we'll do port 11. Okay. So now if I say show monitor, okay, that gives me an idea as to what's going on. Now this is important. Ingress is disabled. That means that on the monitor port you can't transmit data, but you can suck up a bunch of data. So we're going to start here, and we can see that I'm getting stuff from the switch, but not a whole lot going on here. But let's see what happens when we pick up a phone and we go to make a call. No, thank you, Wireshark. So now this skinny traffic right here, this is just the simple keep alive between the call server and the phones. It's nonstop. That's one of the reasons it's very difficult to get rid of a connection. Oh, I lost my delta. There we go. So here is the information going back and forth to the call server. Let's go ahead and pick up. And my goodness, look at all that traffic. Well, all of this traffic right here is RDP. Yep. And we can see at the end, we should get some skinny traffic. And we'll say skinny. You can say, whoops. Skinny will work, but it's the skinny client control protocol, so that will also work, or RTP. Now, the problem is that right now Wireshark thinks that it's not RDP, it's UDP. You can tell, oh, for heaven's sakes, we'll stop this. You can tell Wireshark how to decode this. You can say, I want to decode it as a particular protocol. So, right, I could specify that this is going to be RTP, but that's how you would do it. Okay, so that is a monitor session and how I would watch what's going on in between two phones. By the way, if you set up your monitor session early and then you plugged in your phone, you would actually see it do DHCP, TFTP, then register with a call server, and then you could do all the calls. So you could see all of those things, and that's a good way to really understand what's going on between phones and the call server and then phones and each other. Well, that'll about do it. Let's do a quick recap, right? So I configured the router, gave it IP addresses on each of the interfaces. I configured DHCP pools for PCs and for the phones, and then tested to make sure both of those work. But in the meantime, I also created VLANs on the switch to prevent the DHCP servers from interfering with each other. But also, we generally create separation between PCs and phones anyway. Phones are almost always on their own VLAN. And just for fun, the subnets or the third octet in my network and the VLAN ID all match. And that's just good engineering practice. I then went in and set up the telephony service. I set up where the call server was, and then I set up some details about the phones and the system message. I then went in and created the ePhones themselves and the ePhone dial numbers and matched those up. Made sure I got the MAC addresses correct, so that's important. And then the last thing that I did was set up the TFTP server, fed out the files, and then we did the create CNF files. Plugged in the phones and off they went. There we go. Well, thanks for watching. Thanks for listening to this particular VoIP build. We're going to extend this a little bit by getting two call servers to talk to each other. Well, it looks difficult sometimes, but hey, this is networking. You can do this.